Okay, we are going to continue our skill review for section 8.2, looking at solving quadratic equations by taking the square root or by factoring. All right, problem number 1. We have x squared equals 25. And I've got a quadratic because I have a squared. And there's a couple of ways I can do this. The easy way to do this is just to take the square root of both sides. So I have plus or minus the square root of 25, and the square root of 25 is 5. So I have two answers here, and these answers are rational answers. Problem 2, x squared equals negative 36. I solve this by taking the square root of both sides. So I have plus or minus the square root of negative 36. And again, I know that I can put square root of 36 into the calculator, so I can put square root of negative 36 into the calculator. As long as your calculator is in the right mode, you don't want it in the real number mode, you want it in the A plus BI mode. So you get x equals plus or minus 6i. You have two non-real answers. The plus or minus tells you have two answers, and because this is imaginary, it's a square root of a negative, those are non-real answers. Okay, problem 3, I have x squared equals 13. I'm going to take the square root of both sides. So x equals plus or minus the square root of 13. And there's nothing that I can do to simplify that, so those are my two irrational answers. Problem number 4, x squared equals negative 20. Take the square root of both sides. So I have positive and negative square root of negative 20. And then I'm going to simplify this. I'm going to take negative 20 and break it up into negative 1 times 4 times 5. And when I simplify this, I have 2i times the square root of 5. I've got two answers, and because this I here is telling me that they're imaginary, I've got two non-real answers. Okay, I want to look at some more examples with quadratics where you just have a single term with an x squared. One way that we can do this problem is that we can isolate our variable and then take the square root of both sides. So I have x to be positive or negative 3. Now in this problem, I have an x squared and an x term. So I cannot just isolate my variable in this type of problem. What I want to do is to get everything to one side of the equal sign. So I need to subtract 5x here and here. And remember that the x squareds and the x's are not like terms, so there's really nothing that I can do with combining those into a single term. Now I have everything on one side of the equation and this set equal to 0. I'm going to factor out my greatest common factor, which is going to be x. Now I have two terms that are being multiplied to give me 0. The only way that I can multiply two numbers together and get 0 is if one of them equals 0. So either x equals 0 or 3x minus 5 is equal to 0. So solving this equation, I get x to be 5/3. So my solution set is 0 and 5/3. My next example is also a quadratic with an x squared and an x term. So I need to get everything to one side of the equal sign. It's set equal to 0. I need to factor out my greatest common factor. Set each factor equal to 0 and solve. So I get x to be 0 or x to be 3/2. Okay, problem 5. I have a quadratic, but it's not just an x squared. I also have an x term here. So whenever you have a quadratic, you always want to set it equal to 0 and see if you can factor it. And this is a simple quadratic because it's understood to have a coefficient of 1. If you have a simple quadratic like this and it can be factored, it's good to be factored into something that looks like this, two binomials. So I want to say what multiplies to give me 12 and adds to give me a positive 7. Well, it's positive 3 and positive 4. Once I have that factored, I set each factor equal to 0 and solve. So x equals -3 and x equals -4 are my solutions. Okay, problem 6. Again, I have a simple quadratic because there's understood coefficient of 1 up here for my leading coefficient. So if this can be factored, it's going to be factored into something that looks like this with two binomials. Here I want numbers that multiply to give me -24 and add to give me 2. So I can come over here and make a table of factor pairs. All these numbers here are going to be multiplying, or sets of numbers are multiplying to give me 24. And actually I want them to multiply to give me a -24. So that means one of the numbers has to be positive and the other has to be negative. And if I want these numbers to add to give me -2, then what I want to do is choose 4 and -6. So positive 4 and -6. So x plus 4 equals 0, x minus 6 equals 0. So x equals -4, or x equals +6. A common mistake is that students will get to the second step here, say what multiplies to give me -24 adds to give me -2, and they'll know that it's -6 and 4, and they will write those down as their answers. That's not the answer for x. That's just the numbers that you're going to put in parentheses up here in those factors and then solve.